This is Dr. Sridhar back to you with another video session. So coming to this, now we are talking about induced EMF on the primary side and induced EMF in the secondary winding because of the alternating flux. Now if there is no alternating flux, so instead of alternating flux, if the flux is static in the nature, so transforming the electrical energy from primary side to the secondary side is not possible. Now static flux is nothing but the DC supply. So in that cases, what happens? The primary winding itself, it will induce maximum double the voltage. So there may be a chance of damaging of the primary winding and as well as the first leg of the transformer. This completely spoils the total transformer. So here what happens? Now induced EMF is nothing but majorly in the transformer, especially now we are talking about the single phase transformer. In the single phase transformer, whenever the supply is connected to the primary winding, now there will be a flow of primary current through the primary winding. So whenever this current flows through the primary winding, now there will be a magnetic flux in the primary winding. That flux is nothing but alternating in the nature. Now let us take the same flux here, because now why we are concentrating on the flux means that is the only common and constant parameter from primary to the secondary. Suppose if you are taking the voltage in the primary and the secondary, there may be definitely there will be different currents. Now if the voltages will be different, automatically currents will also different. Now which parameter is common from primary to the secondary or in the primary winding and the secondary winding means now flux will remain constant anyhow, but of course it is related to the magnetic circuit. Now anyhow flux is also constant. In addition to that, one of the electrical quantity, which is nothing but the frequency, that also remains constant. Now from primary winding to the secondary winding. So now what is the flow of this flux means this is the alternating and this is the alternating flux. The alternating flux, it reaches to the maximum value in the quarter cycle and then again it goes to the zero. Then again negatively it will be increased. Again it will come back to this one. So here along with the flux, already we discussed that frequency also remains constant. If the frequencies remains constant, then reciprocal of the frequency, it is nothing but the time period. The time period is nothing but from here to here, that is the time period T. So in 1 quarter, it will reaches to the maximum flux. So within 0 to T4, now it goes to the maximum. Then again, in the next T4, it comes to the 0. Then again, the next T4, it will be negatively maximum. Again, in the next T4, again, it will come back to the 0. So like this, the flux is passing through the magnetic core from primary to the secondary by having the frequency as a constant, because this time varying, it is a time varying flux. Time varying flux means along with the time it will change its magnitude, and with this simple waveform, we can also say that flux is the time varying one and having a time period of capital T with a frequency F. So the average rate of change of flux is nothing but average rate of change of flux means now if you could say this first quarter, now flux is changing its value from 0 to and it is going to the pi maximum, and for this how much of time the flux is taking means 0 to T4. So average rate of change of flux is nothing but average change of flux is nothing but 0 to pi maximum. Rate of change means that should be divided with the time. So pi maximum minus 0 to T4 minus 0. So pi maximum divided by T by 4. This is nothing but pi maximum by T is nothing but the 1 by F. So that is also we are representing here. Pi maximum is equal to 1 by pi maximum by 1 by 4F. The average rate of change of flux is nothing but if you are simplifying this, now 4F it will come to the numerator. So 4F pi maximum Weber per second. So induced EMF per 1 ton. How many number of tons are there? That will also influence here. So induced EMF per 1 ton is nothing but average change of flux into some other parameters also we have to multiply. Just try to recollect the fundamentals of AC circuits. Already we have discussed in many times with our previous videos. So induced EMF per 1 ton is equal to rate of change of flux per 1 ton. This is the same thing in the same sense, because as per the Faraday's laws of electromagnetic induction also, it is very clear per 1 ton is nothing but the rate of change of flux per 1 ton. So therefore, average EMF per 1 ton is equal to 4F into pi maximum, because already just now we have calculated average rate of change of flux. This is nothing but average EMF. So average is nothing but it is a word. Otherwise, this is nothing but the RMS value only. Average EMF per 1 ton is equal to 4 times of F into pi maximum volts. So, but we require RMS value. The average value is not required because even though if you are connecting any voltmeter or ammeter to record the voltages in the primary or voltages in the secondary, currents in the primary or in the currents in the secondary, generally meters represents or it indicates the RMS value. So that's why better convert this average value to the RMS value. So for a sinusoidal, because we know that the property of these quantities are nothing but alternating property, alternating quantities. For any alternating quantity, now we know some of the constant parameters like peak factor, form factor, etc., etc. But here, which factor we have to select means now available value is average. We require RMS. So let us take the ratio between the RMS value to the average value or RMS value to the average value. Which value is known to us? Let us take that ratio because we know that these values we are computing for the alternating quantities. So RMS to the average value, we know that there is a formula available for us from the fundamentals of AC circuits, which is nothing but the form factor. So the RMS value of EMF per 1 ton is equal form factor into average value. So form factor is nothing but 1.11. I think if you could recollect it, it is well and good. Otherwise, you please refer our previous videos where we have elaborately, we have discussed and we have given some calculations, simple examples. And for various waveforms also, we have computed form factors, peak factors, etc. I hope that videos will definitely will helpful for you. So the RMS value of EMF per 1 ton is equal to form factor into average EMF. Already we have computed average EMF per 1 ton. That value is equal to 1.11 into 4 times of F into pi maximum. This is 4.44 F into pi maximum is the RMS value of EMF, induced EMF per 1 ton. And here we don't know whether this happens in the primary or in the secondary. So induced EMF in the primary winding means in the primary winding how many number of turns are there? N1. If it is multiplied this value with N1, you will get the induced EMF in the primary. If it is multiplied with the number of turns in the secondary, you will get the induced EMF in the secondary winding. That's the thing we are calculating here. So RMS value of EMF per 1 ton into number of turns in the primary is nothing but, so induced EMF in the primary is equals 4.44 F into N1 into pi maximum. Similarly, this is the secondary induced EMF in the secondary winding 4.44 F into N2 into pi maximum. So this equation 1 and equation 2 are called as the EMF equations of the transformer. So EMF per number of turns is same for both primary and secondary winding. Just now also we can see that. So per EMF E1 by N1, if you could take E1 by N1, that is the induced EMF per number of turns is nothing but 4.44 F into pi maximum. That will be same for primary winding and the secondary winding. So if you could see for ideal transformer, E1 is equal to V1 and E2 is equal to V2. So what makes the difference E1 and V1 means, now if the supply voltage, if it is connected, then there will be a flow of energy, electrical energy to the primary winding. So that particular winding, that primary winding will have some impedance. Naturally it happens. So if that impedance, if it is ignored, because that's why we have mentioned here it is ideal transformer. If it is an ideal transformer, then the impedance or the losses because of the impedance or losses because of any other thing or the drops because of some various passive parameters can be ignored. So in that cases, if there is no loss, whenever that electrical energy is transforming from supply terminal to the primary winding, then that becomes E1 to V1. Similarly, that holds good for secondary winding also. E2 is equal to V2, where the V1 is equal to supply voltage of the primary winding, V2 is equal to terminal voltage of the secondary winding. So transformation ratio also, even though we have discussed well in advance that E2 to E1 is a transformation ratio. Now, so in that cases, V2 to V1 will also becomes the transformation ratio. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.